Hey, welcome back, physicists. This problem is easier than you might think. Looking through it, unfortunately, we don't have a ton of knowns and things like that. One weird thing that we started doing last class, when we have an incline, what does that change about the way we draw our motion diagram or a coordinate system or anything like that? Yeah, we tilt it, right? Okay, so I don't care which way we go here. Are we tilting up like this? Is it what? Is this our incline or is this our incline? Positive slope or negative slope? Okay, I am fine with that. I usually go the opposite direction, but I'm good with that. Okay, so here it is, and here's our object, right? Okay, this is the x-axis, which the reason I usually go the other direction is because right now that's negative x and that's positive x. Okay, what else should I add to this? Hey, the y-axis. Cool, let's do that. So here we go. It doesn't ever look perpendicular on my screen when I draw it, but that looks actually pretty good this time. There's our y-scale. Now, as we look at this, I don't have really that many things known about this equation or this situation. I know that I have a suitcase sitting there. That's my dot. Will the component of the suitcase at what angle? Will the component parallel to the plane be equal to half the perpendicular? So, we don't know the angle. If we think of it, and I don't want you to draw this, but it might help just to envision it, this is our ramp. Okay, with that being in mind, I know that that's an angle theta, and then this is always weird how it works out. If I draw gravity on here, what color is gravity? Okay, let's go green, sure. All right, here's the force of gravity. It pulls straight down on this object. Where's theta in this picture, and how on earth are you going to describe that? I guess you can. Where would theta live on this picture with respect to gravity? Between which two rays, we'll call them? The y-axis, and this. Okay, that's theta. Now, when we're dealing with this, I don't care which way we go with, and it really doesn't matter. Do you guys want to, and I know I've asked this about a million times already, but it might change from problem. Did we draw the triangle like this the other day? Or did we draw the triangle like this? The first one? Okay. And I'm fine with that. So as we look at this then, check it out. If this is the force of gravity, I can always go from the terminal location, the ending spot of that force, and I can break this into its components. I'm going to go either perpendicular to the y-axis or the x-axis. As long as it forms my right angle, we're golden. Let's do it here, perpendicular to that one. And I assume that's what we did. This red line is the force of gravity that's parallel or perpendicular to the plane. So it's perpendicular to the y-axis, 100%. To the ramp itself, though, it's parallel, right? It has to be. So I think we called this F parallel the other day. Now, in the other direction, this is still a right triangle, which means I have a hypotenuse here opposite the right angle, and then I get these two legs. This blue one that I just drew is the force that is what to the ramp? Louder and more confidently. That was a little louder and a little more confident, but I agree it's perpendicular. Okay, notice the only thing that gets weird about this is that if I had done the other triangle, we get the exact same numbers, but my trig functions make sense. Cool. All right, what are we trying to do? And we rewrote this question because it's so ugly. I want to know at what angle, so what theta, and I'm just going to reword this, and it's going to be a little bit different than we did the other day because I don't have it written down. What theta such that what is true? The parallel force is equal to 1/2 the perpendicular force. Okay. And I'll go ahead and make sure my colors match. 1/2 the force is perpendicular. Everybody on board with this? Okay. Who in here loves fractions? You just want to deal with them all the time no matter what? Okay, so how do we bust that fraction? Good. I didn't quite hear what you said, but I think it was reciprocal, which makes me think 2. I'm going to multiply both sides by 2. Cool. 2 times the force of the parallel. Oh my gosh. I wish there was an easy button to just change colors. Equals the force of perpendicular. And I think this is probably where I left you guys the other day. The video I might have gone one step further. I don't remember because I had to re-record it because my program's dumb. Cool. Well, here's the only thing that we need. If we don't want to just blindly follow trig rules, which I'm cool if we don't, we're looking at this triangle. If I want to think about how to, bless you, not what I'm thinking about, but if I want to try to find the parallel force, I'm assuming that eventually we would know the mass, which means we could find the force of gravity. I can find that force of gravity to mg, right? So let's just look at this. If I wanted to rewrite this parallel vector, and I knew the force of gravity, what trig function would I use from this theta if I have this green and this red? And to help this out, from this angle theta, this is the hype. What is this one? Adjacent. And this is opposite. Okay. Which trig function for that one? Sine. So I'm just going to go into this a little bit further. I'm going to quit changing colors. I'll just do all red for this side. That means that I would get 2, and then it's going to be sine. How do we deal with this? It's the force of gravity, right? That's my magnitude. Fg times the sine of what angle? It's just theta in this case, right? This is how you find the components. The magnitude of the gravity, or the resultant, we'll just say gravity. And then sine theta cos theta, right? Now, that is going to be exactly equal to, how do we do the perpendicular force? I know that it's going to have an Fg in it, because that's the strength that we're pulling straight downward. I need the component. Gosh, what about this blue one? If we know the hypotenuse and we're dealing with the adjacent, cosine of theta. Okay. If you draw a good picture, you never have to worry about trig stuff getting weird or trying to remember anything, because we can just use the triangle that we have. Not the way that I typically do it, but it works. All right, well, what are we trying to do? We're trying to solve for what? Theta. So I need to get, just per regular algebra rules, I need to get anything that has a theta in it on one side of the equation. I can clean this up a little bit nicer than that. What do you guys notice is on both sides of this equation? The force of gravity. It's just some number, right? And it's the same number. What could I divide both things by? I'm going to divide both sides by the force of gravity. So it does this, the force of gravity, and then we wind up one step further. Can I do one more line of work in this? If I want to, so we can't divide by theta, because theta is stuck inside of my trig functions. I can't just divide by it. To undo a sine or a cosine or whatever it is, we have to deal with inverse trig. But remember, my first goal should be to get everything with theta on one side. So if we're here, 2 sine theta is now equal to cos theta. I would have done this in one step, and I think a lot of you guys would have as well. What could we do? One more time. Sorry. I didn't hear what you said, Rafa. Divide by cosine. I could. Could I divide by sine instead? I would probably divide by sine so that I don't have to move the 2 again. But if you have already divided by cosine, would you guys all divide by cosine? Okay, let's divide by cosine. I'm good with that. We'll divide this side by cos and this side by cos. And I'll work up this direction. What's my next line read then? On the left, we have 2. I'm going to rewrite this just a little bit. Sine theta, cos theta, or over cos theta, I'm sorry. Equals, what remains on the right side of this equation? 1. Okay. I'm trying to solve for theta, right? And the algebra rules, they just say, hey, get everything with theta on one side. What should I multiply or divide both sides by now to make it so only stuff with theta is on the left? You're not going to be wrong. What number am I multiplying that ugly fraction of trig fractions by on the left side of that equation? How do you undo a multiply ugly fraction by 2? Divide by 2. So if I go one more step, I'm thinking sine theta over cos theta equals 1/2. Have I lost anybody along the way yet? Now, in mine, and I'm going to jump in here, I'll show you the route that I would have gone, but we get the same answer. I made you guys write one more thing in your notes last class. We did a couple trig comments at the very end in your notes. Check for me the two that we made. Holy cow. Sine theta over cos theta has a definition. And we saw last class, Nick found it right away. What is sine theta over cos theta? It's tangent. Y over x, opposite over adjacent, however you want to think about it. I'm going to rewrite this expression, tan theta equals 1/2. Now we're cooking. It's looking simpler. No brain rot intended. That's like generational language, just so you guys are aware. How on earth do we get the dang theta out of that tangent?
I spaced it out. How do you get the sine over cosine tangent?
So this is just a definition. The very last thing you should have in your notes from Friday, sine over cosine is defined as tangent. Yep. Man, how do you undo a tan other than wait for winter? God, this guy is so good. Thoughts? Somebody knows. I'm going to take the arctangent of which side of this equation? Simplify that. Both. Cool. All right. I'm going to take the arctangent of each side, and I wish that this would catch on as a norm everywhere, where arctangent or inverse tangent is used with a capital T. Drives me crazy that it's not. I hate it. Well, man, that's pretty good. Love, love, love. What did you saw Abigail do? Abigail, will you just make sure you stand up and show everybody what you're doing currently? Oh my gosh, he's calculating it. Fantastic. Double check on them calculators. Let me know if you get the same thing. Black Friday deals are going. I'm ordering so much balsa wood to do just construction stuff in all of our classes. I'm also waiting to see if I get a fancy controller for sale. Yep, I know what you're talking about. Yeah. What is the arctangent of 1/2? 26.57 what? Degrees. Somebody second that? Cool. Looking at this. We have not hit the trig stuff super duper hard in pre-calc yet. We're not going to for a little while. But you guys have seen, I think, and correct me if I'm wrong, have you guys seen all this trig stuff before? You maybe don't remember it. Yours is different. But I guarantee last year in Algebra 2, you guys did. I don't know how much you recall. Maybe a lot, maybe a little, maybe nothing. How much trig do you remember, Delilah? Do you remember all this stuff? Okay, cool. Awesome. I want to highlight here the only thing that I would have done different. If I were doing this problem, you guys elected to divide by cosine. I would have divided by sine and got this. Cosine of theta over sine of theta. And this looks upside down to me. This isn't just tangent anymore, right? It's backward. Anybody remember what it is? Okay, that's right. It is the cotangent of theta. This is how I would do this problem. And turns out if you look at tangent on your calculator, I bet, oh, no, it's not on your fancy calculators. We have to go into the trig menus to get it. Makes sense you guys would do it like this. Sine over cosine is what you want. Go ahead. That's what I just did. I would use cotangent. This is what I would have done instead. And we just don't have that definition. We know that sine theta over cos theta is tangent theta. And then it works out that if we flip this, we could do cosine over sine. And we just call this equal to the cotangent. Have you guys ever heard secant, cosecant, and cotangent? Okay. Cotangent. What's up? I haven't yet. Yeah. I'm going to show you guys this real quick. On your calculator, there's a math button underneath alpha, third from the top on the left side. Make sure everybody, at least one person in your group, has it. If you hit math, and we go to, oh, we got to find it in here. It's been a long time since I've done this. Let me see if it's in here. All right, scratch that. I don't really want to make you guys do this. I'm going to show you it, though. I lied. Don't hit math. Go back to your home screen. Okay. Do you guys see what's written in blue above 0? What's written in blue above 0? Okay, if you go into the catalog, second 0, and you go all the way down until you get to C. And we keep going. I'm looking for cotangent with a -1 exponent connected to it. Do they have it? Oh my gosh, do they have it? I have cosine. I lied. We'll just use tangent on these calculators. I don't remember how to do it, but I'll figure it out for you guys. We'll just commit to tangent. Deal? I know it's in here. I just don't remember. I prefer a different calculator, but that's all right. Cool. Well, I want you guys to try 1 and 2. Baller. Okay, I'm going to give you like 10 minutes to work. I think I'm going to go make some copies. I think. I'm going to give you guys some time. Chat it out. You're doing numbers 1 and 2. Here we are, right off the bat. I'm going to check. Love how you started. Is that the phone? Okay. Love it. Love it, kind of. There's some of it that I don't, but we'll talk about it. Love how you started. I'll take some. Did you get that? Okay. All right. So looking at it, here's how I would always go about these. I know that it's a, 15-degree angle? Am I going to draw that to scale? Not a chance. So check it out. Here we go, 15-degree angle. Here's my x-axis. And it doesn't even have to be that big. I don't know why I drew it so large. Okay, here's the x-axis. Baller. And here's a cup of lemonade sitting on the table. Also baller. And I need to add what other axis? Baller. Everything's just baller today, just so you know. Cool. That does not look perpendicular on mine. Does it to you guys? I don't know what it is. Here it looks fine, but it's just this angle that I can't remedy it. All right, it's perpendicular. Okay, what forces are acting on the lemonade? Gravity it is. So check it out. Here's gravity. And this angle here is what? 15 degrees. Okay, there's a force of gravity. This is essentially the same diagram that we just drew a moment ago. Cool. We are trying to find the components of the weight that are parallel and perpendicular. So pretty similar problem. Am I going to use a little triangle going over to the y-axis, the triangle going to the x-axis, or a third option? Everybody use a little triangle, I assume? Okay. So I won't even talk about the third option in case unless you're wondering. We're looking for the force that's parallel. I'm going to add a right angle here. This red line is parallel or perpendicular? Parallel. And the, let's see, green line that I'm about to draw, is it perpendicular? F, perpendicular. Cool. Now, if we know that this is 15 degrees, all we're really looking at is this triangle at this point. Cool. Let's write down our knowns and see that this problem, not too terrible. What's the mass? Is that a lot of lemonade? It's like 16 ounces. It's half a liter almost. Okay. I have theta is 15 degrees. And that's it. Cool. If I want to find this, let's do F parallel first.
Is that 15 degrees, the angle on the inside?
It is this one right here. Yep.
Is that that's because it's being lifted 15 degrees? Oh yeah.
Yep. Remember that big old deal with the triangles and where the similarities live? Here's the 15-degree incline of the table, and it turns out that this is the same via that triangle similarity stuff.
Yeah.
Okay, cool. Well, let's find F parallel. I'm good with that. Now, I know it's going to require the force of gravity, and then to get this side from this theta. That's all I need to look at. Which trig function, because I think we can find the force of gravity here in a minute, which trig function do we use to get that red side? It's going to be sine, right? Opposite over hypotenuse. Cool. So FG times the sine of what? You're right, it is. But I'm just going to say it's 15 degrees. If this part feels like magic, because we're using sine in this direction, that's what bugs me about it. If you need to write out the following, you can, but don't write it unless it's absolutely necessary. If I had just asked the sine of theta, do you guys agree it's opposite as F parallel over the force of gravity? Opposite over like that's what it comes out to be, right? This is where I'm obtaining this. I'm just rearranging sine theta to solve it for that by multiplying by FG. All right, let's go one step further. How do you find the force of gravity or an object's weight? Okay, yeah, you're right. Mass times gravity, or the acceleration due to gravity. So this becomes mg times the sine of 15 degrees. And here we go. If we look at this, m is 0.44. What's g? And last but not least, the sine of 15 degrees. When you type this into your calculator, you're going to get a number. I don't remember what the number is. I guess I do, actually, but it's like 1.12. Okay, moment of truth. You have some options at this point. Anybody in here absolutely hate the trig? Interesting. Okay. If you do and you're just being shy about it, how many sides of that right triangle do we know at this point? Could we find the third using not trig? Thank Pythagoras for that. You could use Pythagorean theorem if we wanted to find it with trig. Problem's not really any harder. If I want to find F perpendicular, it is equal to, and let's see here, which trig function do we deal with that has adjacent and hypotenuse? Indeed, it was quietly whispered cosine. FG times the cosine of 15 degrees, which we already know FG is just 0.44 times 9.8 times the cosine of 15 degrees. I personally think this is faster than using the Pythagorean theorem. I don't know what it comes out, just kidding. I bet it's like 4.17, which is what I think Tully got a second ago. Cool. Yay, nay, what do you think? Yep, so I know that as this thing sits here, what we just found is pushing it or pulling it down the ramp due to gravity is roughly 1.12 newtons of force that's pushing it down. And then pushing the normal force of this object is this one. So that obviously the ramp pushes back, but we found it's 4.17. Those are what we just determined. Cool. Doable? Okay. In a pure math context, and I commented the other day that sometimes I will do a little bit of fancy stuff so it makes more sense in my head. I use this angle here just so that I can deal with X and Y being in the appropriate places. There's one more option that if you're feeling crazy, I encourage you to try out, but I'm not going to require it. I'm not even going to go through it. Could I measure this angle like this? like we would in a regular math class? Man, I bet if we did this, we could find the force of gravity times the cosine of that big angle and the sine of that big angle and cut out like all the middle work just by feeling comfortable with the trig. My apprehension about doing this instead is that when you inevitably type this in, looking at it, there's something like if your picture's a little bit off, you're going to destroy yourself. Once we do stuff in pre-calc, this idea I think will probably be the go-to. Is there anything else that you think worth considering that maybe one little issue with the answer? The force that moves down the ramp is in the positive direction, right? 1.12, that makes sense. What should the force of gravity be? Are we saying find the components of the cup's weight? The gravity, does it go down y or up y? So let me rephrase that because that's a weird wording. Gravity pulls it upward or downward, right? So it actually pulls downward, or it's a normal force if we look at it like that. They're the same thing. Cool. I would probably call it negative. I'd say it's pulled downward toward the ramp at that much, just to clarify the answer. When we don't deal with the actual math of it and we're trying to like skirt around it like this, the sine stuff always ends up the weirdest. Okay. Your chance. Last one. Not really chance, but another golden opportunity for you guys. I want you to do number 4. If you have an answer to it, because you've already been working as I was going, or sorry, number 2. I misspoke. What am I doing? If you already have an answer and you want to check it, I got you. I'm going to give you guys a couple minutes. Cool. We have her chair being tilted. Cool. It happens. That's a dentist. Here it is. Now, we'll say that here is her, right? And here's our y-axis. Hate it. Still hate it, but that looks a little better. No, it doesn't. There we go. Okay. Here's our positive x and our positive y. This, I imagine, is everybody's hopefully first step. I can't draw x's and y's today. Okay. Here's her. Gravity pulls her straight downward. Okay, and now this part is just terrible language, and I didn't write the problem, but it's pretty common to see in this type of example or this type of problem. We're told that her force is 449 newtons perpendicular to the plane of the seat of the chair. Now, going through this, couple different ways that we're looking at. I lied to you. You were right. I'm sorry. You guys were right. Okay. What's the plane of the seat of her chair? Say that again. So she's sitting here, right? The plane, her chair, assuming makes a flat surface on the bottom because it's a chair. This is the flat surface that her chair sits on. Okay, which means the part of my force that's perpendicular to this is right here. And that's my bad, Riley. Or Nick, whomever. Okay, this is the force that's perpendicular. Now, my notation when I do these, you can use F perpendicular like we have been. I called this on mine force of gravity in the y direction. This is how I denote it instead of saying perpendicular. Okay? Which means if I want the part that's, oh, we don't even need the parallel part, do we? Oh, piece of cake. But if I wanted to draw it, it's here. This is the force of gravity in the what direction? X. Now that's how I denote this, but if you want to use parallel and perpendicular, I'm fine with that. We're just looking for the purple one. Okay. Well, I have some stuff given. I know her mass. That's pretty handy. What do we know? And I'm going to write it all out. Did you guys get answers and you don't need me to talk about this? Okay. If you've got an answer, I'm going to make a deal with you. If you have an answer that is 23.61 degrees and you give me a like somewhere to go from, so as long as you can specify where that angle actually is, you're cool to use the next 9 minutes to study stuff. Like, I don't know, pre-calc maybe? If you want to work through this problem, we're going to finish up this problem right now. And then here in a few minutes, we'll talk about what's going on tomorrow. Okay, I know the mass of this girl, woman, whatever it is, 50 kilograms. Cool. What, based on my picture, am I going to write is 449 newtons? Force of gravity in the y direction. That's this one, perpendicular to the chair. or the surface of the chair, the plane of the chair, however you want to word it. And that's where I lied to you. I was wrong on that when I just read through it the first time. Okay. That's what I know. What am I trying to find? Okay. So I'm trying to find theta. And then there's another piece in here. This is theta. Cool. Gosh, if I want to find this purple one, the force of gravity and the... Sorry, if I want to find... What am I looking for? The angle. If I want to find theta... Sorry. I know FGY. That's the adjacent side to it. Is that right? Ooh, we do know the value of gravity. Could we find the force of gravity as well? If I know gravity is 9.8 newtons, could we find FG? Okay. I'm going to use a little shortcut here. If you take 50 times 9.8, you can get 490. Is that right? Good. Okay, so check it out. We now know that this has a length of 490 newtons. This purple one has a length of 449. Man, if only that were enough to find my theta. Wait a second. What sides of the triangle do we have here? We have adjacent and hypotenuse? Well, gosh, what trig function could that possibly be? So I know that the cosine of theta is adjacent over hypotenuse. Am I plugging in numbers or am I using variables? Okay, I'll do variables first. Adjacent is FGY, and hypotenuse is FG. If I want to find FGY, I just multiply both sides by FG, right? Anything crazy going on mathematically? Do I know both of them? I think so. Now, let's just plug in what we know. What is going in for FG of Y? And I don't know why I expanded here in hindsight, because I'm just going to undivide it. I forgot how to solve them for theta. I'm going to scratch that. I'm not going to erase it. Could I solve this for theta right here? Yeah, I probably should have just done that. By doing what to each side? The arc cosine. And then I'm going to, instead of doing FGY over FG, I know it's 449 over 490. And I bet you get 26.1. I think. Do we get 26.1? What do we get? 23.6? There's the numbers. Okay. Sorry to stress you out there. I had all the numbers just in the wrong places. 23.61? Okay. And that answer, love the answer. The number's perfect. But if I just said, draw me a 23.61 degree angle, how many of you think you would draw that theta right there? I don't believe you. But there's an easy way we can do this. We're not really working on a compass, but I'm okay if we deal with this. I'm okay if we say start at south and go that far. What direction? West. I'm cool with this. My mathematical brain says I prefer, rather, if we go 203.61. That's what I prefer. 180. Well, it's going to be way more than 203.61, isn't it? It's going to be 180 plus, oh, what's this complement? I don't know. The big angle here is what I want to write. It's not 203.61. I added up the wrong thing. 270 minus 23, 246.39. That's a better answer. Cool. Okay. That's our chapter. Oh, man. I am thankful that you guys are just so committed to wanting to take a test tomorrow rather than waiting 6 days. You are thankful for lots of stuff. My funny jokes, I imagine. Impeccable sense of humor. Gosh, there's just lots of them. My Cowboys fandom. I'm going to let you guys take a quick look. I'm going to show you the test. Okay, tomorrow in class we will be doing the test. I'm going to show you the very top page of it. Ta-da! You guys get the hour tomorrow in class to work on this, as well as the Thanksgiving break to be thankful for a take-home test for this chapter. Cool. All right. I'm not giving any additional homework tonight. We got 3 minutes. If you have random trig questions or pre-calc questions or funny anecdotes to share, I'm cool with them. Otherwise, uh-oh. Okay, so it is the holiday season. In the future, I probably won't do this live. Have you taken the time to work through most of them? I feel like you're going to be sitting around over the break. It's a super long time ago. Here's what I'm going to do. Your 3 hours left, 6 hours. If you want to take it in a 6 hour, I have no objection to it. If your score is better, I'll give you the benefit of it. If your score is worse, I'm not counting.
What?
Don't wait so long.
When?
That's unreasonable for you? Because without your tests, either typically I say no, but sorry.
I have a question.
I have an answer.
You know that part right here where you kind of for this, I decided to try to put the
So it's in my head I was trying to solve for FGY.
I know, but if you were supposed to
I'm multiply by FG. This is just a number. So to undo a divide by FG, we just multiply by FG. They're just fractions. We treat them as every other fraction.